All right, so the best way for this first one is probably to remind ourselves we're doing question 1. So we need a balanced equation for this. Might have to use tables from online or some other textbook if you don't see these. Okay, we gotta balance these. So you guys will probably do this better than I can, so I'm going to try and do this on the fly. So one of these half reactions looks like this. And we first have to balance the number of H's. You balance number of oxygens. This side has 6. All right, this has 4. So I believe you're supposed to balance using oxygens from water. So this side needs 2. So now we have a problem with H's. 4 H's over here, 1 here. So I'd have to balance using acidic medium. Is that right? Yeah, it's a lead acid battery. So this looks like a balanced half reaction, if you will. Lead right here is +4. Lead over here is +2. So obviously the charge of this, well, and I think you know, I'm looking straight to the source here. The number of electrons is going to be 2, but you can see you've got 3 and a -1, so that's +2. So I'm going to add on 2 electrons to this side. And obviously this is getting reduced. And when I looked up in a book, there'll be an E0 for that. You can look it up. The other half reaction was PbHSO4 negative, and it goes to PbSO4. Okay, so this is 0, and this is +2. So this is obviously getting oxidized. But we start with the oxygen. There's 4 oxygens here, there's 4 here, so that's good. There's 1 H here. We need to tack on 1 there. So H's is balanced. We have negative and a positive. So we can see it's 2 electrons. So this now looks balanced. So this, I believe, is where we would then say one of these will kill this off to make it a 2. These cancel. So this looks like PbO2 plus some lead. Plus 2 of these, plus 2 H's. Does that look right? I guess it does. 2 PbSO4s plus 2 H2Os. This half reaction, you look it up. Now there's a note here, our textbook for this one, I believe, our book had a number of 0.3505 volts. Oh, wait a minute, no. This number I got from a different one. Our textbook for this half reaction had 0.3588. Long story short, folks, I don't care which one of these you looked up for this. Whatever one you find for this, you add these 2 numbers together, right? E0, to get this. Now remember, the way we've done this number ends up being a positive number. So what that means is the direction we've written this is the direction of spontaneousness. So this means a lead acid battery, when you head this way, right? Because it's spontaneous. If you charge your battery, you're going to put this in reverse, right? So, I don't know, what is this question A? Write out the balanced equation for E, blah, blah, blah. Okay, so part A, we balanced it. You will find an official E value. It will be a positive number, so that lets you know which way is charging, which way is using it. So on to B. If the battery was charged at 12 amps, so the current is 12 amps for 2 hours, how much lead sulfate will get decomposed? So we're running it backwards, this way, that way. Your E value will tell you, and this volt, by the way, is joules per coulomb, right? So, correct me if I'm wrong, this reaction, whether it goes this way or this way, it's 2 electrons. So it's funny how what's going to happen is, we know you're thinking, you know that Nernst equation, that nu, which is related to the number of moles, if you will, of 2 moles of electrons. So when I'm charging this, current is coulombs per second, right? So 2 hours, you're running this. So if you multiply this by how many seconds are in an hour, it's 2 hours, and each hour is 60 minutes and 60 seconds. So that's 3,600, right? So you're going to get a number in coulombs. Coulombs, when you're charging it, this is literally the number of electrons. We can calculate through that. Somewhere in the front cover of your book, you can convert coulombs to electrons. So coulombs, correct me if I'm wrong, isn't it 1 electron is 6 times 10 to the minus 19 coulombs? So when you calculate how many coulombs over 2 hours, take that, turn it into numbers of electrons. So you'll get a number. This will be some number, and it will be big, huge, of electrons. You want to convert that into moles of electrons. Think about it. If you had an answer, some number in mole, we'll call this number you get D. Once you have D moles of electrons in this 12-hour or 2-hour thing, you could take D, that number, moles of electrons. You want moles of PbSO4. We know in the balanced equation, 2 moles of electrons is getting transferred for every 2 of this. So the recipe is telling us it's 2 to 2. So whatever D moles of electrons you have, you're going to have, let's call it E, which is equal to D moles of PbSO4. Once you get moles of that, then you multiply by the molar mass to get grams of that. And I can tell you the number, let's just say the number is somewhere between 200 and 300 grams. That's a ballpark range of what your answer should be. So that would be the grams of lead sulfate that's going to get pushed back, deteriorate or decomposed back to form some lead and lead oxide. And it turns out that this has nothing to do with the E value. All you need is just this. So that's question 1.